questions 21 through 25 on the 2005 Pascal Math Contest. Integers m and n are each greater than 100. If m plus n is equal to 300, then m colon n could be equal to the ratio m over n. I prefer to write it like that. All right, this is what this is what I call a time drainer. And on math contests, you have a limited amount of time, right? You only have an hour to get through 25 questions. It's not a lot of time at all. And this one is going to drain at least 6 minutes of your time, which is unfortunate. The only way I can think of doing this question is to go through each answer choice individually. And I'm not going to do that because you're going to get bored. So I'm just going to show you how it's done. Let's say I think the answer is 3 over 2. Therefore, I'm saying that 3 over 2 is m over n. Okay? So cross multiply and you get 3n is equal to 2m. Isolate for one variable, you get 3n over 2 is equal to m. Now plug it back into our main equation, m plus n is equal to 300. M we just wrote or figured out was 3n over 2, and you add that to n. And if you do, you get a common denominator, you'll get 2 over 2 like that. So it'll be 5n over 2 is equal to 300. 5n is therefore 600, and therefore n is equal to 600 divided by 5, which is 120. Substitute n back into here, and that will give you m is equal to 180. Now, are both of these greater than 100? Yes, they are. And both of these add up to 300. And therefore, the conditions are met, and the ratio is indeed 3 over 2. Now, I all of a sudden, decided to skip to choice E. Unfortunately, that was the last choice, right? So you probably, if you're doing this question in order, you'd go through A, do this, B, do this, C, do this, D, do this, and think, oh, geez, how much time has gone by? So it's just one of those time drainers, and the important take home with this is that you just got to be really fast. So number 21, the answer is E. In the diagram, 2 pairs of identical isosceles triangles are cut off of square ABCD, leaving rectangle PQRS. The total area cut off is 200 meters squared. The length of PR in meters is. All right, well, these are isosceles triangles, so I just labeled them. This is X from here to here, A to P. A to S, I'll label X. And since they're identical, this is also going to be X, and Q to C will also be X. And in a very similar way, I will label these guys Y's. All right? Now we are told that the area of that shaded region is 200. So using my variables, it would be 2 times 1/2 base times height, correct? For the area of the triangles that I've labeled X. And the Y's would be 2 times 1/2 base times height. And they have told you that is equal to 200. Okay? So if you do the math here, you just get x squared plus y squared. So we'll leave that alone for now, and we'll come back to it a little bit later. Now they want you to figure out what is the length of PR. So PR, which is from there to there. Correct? Okay. I think I know what to do here. We are going to use again our famous Pythagorean theorem, but this time I'm going to use it on this triangle right here. And that means it'll be x squared plus x squared is equal to ps squared. And then I will use the Pythagorean theorem once more, but this time on this triangle, this little guy. that one gives y squared plus y squared is equal to SR squared. Okay? Now, the good news is I've got PS, I've got SR, and I can figure out PR, again, through Pythagoras. And you say, well, how do you know that? Well, because this was a square, so that was a right angle, and this is a rectangle, so that's also a right angle. That's how I know. Okay, so we got our final Pythagorean relationship, which is PS squared plus SR squared is equal to PR squared. Okay, PS we just figured out was 2x squared, and SR we just figured out was 2y squared. PR all squared. Factor out a 2 and we get x squared plus y squared. Now x squared plus y squared we figured out was 200. So substitute that in there. PR all squared. And then that is going to be 400 is equal to PR all squared. And therefore, if you take the square root of both sides, PR is equal to 20. So number 22, the answer is B. Starting with 2, the number 2005 can be formed by moving either horizontally, vertically, or diagonally from square to square in the grid. How many different paths can be followed to form 2005? All right, no problem. Let's do this in a systematic way. I think I'm going to blow this up a little bit. Okay, I think that should be good enough. I'm going to label this 1, 2, 3, 4, 5, 6, 7, and 8. Okay? And we will talk about these a little bit later. But let's take this one step at a time. So we're starting right here, right? In the middle. And we've got to create 2005. So first, let's concentrate only on this guy right here. And since I've labeled it 1, I will just call it 1 right there. Okay, so we're starting here and we're going here. And that's all we're doing for now. Okay, now once we get to here, that is what I'm going to concentrate on. What are my options? Well, at that point, I've only got 2, 0 as my number. I've got to create 0, 5 as my next 2. Well, to create a 0, I can only go here or here, correct? So let me draw that here. I've got a 0. I can only go here or here. Okay? Now, when I get to this guy right here, which is represented right here in my diagram, I have to get a 5, right? Because I'm at 200 so far. That's no good. I got to get 2005. From here, how do I get to a 5? Well, I can go either here or here or here. So I'll draw that in right here. I can go that way, a 5, up a 5, and this way, a 5. Okay? In a very similar way, I start here, I go to here, and then I go down here. This is what this one is represented as. And how do I get to a 5 from there? I can go either here, here, or here. Correct? So that's 3 ways, and I'll draw those in 5, 5, and 5. And that's it. So how many different paths? I got 1, 2, 3, 4, 5, 6. 6 paths for the first guy. I'll just put 6 there. Okay? Now, what's interesting about this is what is very helpful in my opinion is that all these guys, the corners, have the exact same story. So what that means is that there'll be 6 for 3 for this guy. There will be 6 for 6, this guy right here. And there will be 6 for the 0 that I've denoted as 8. Okay? It's the exact same story, and you can do that just to verify. So far I'm doing good. I've got 24 of them, but these answer choices are obviously bigger than 24, so I've obviously got to get more. Now let's concentrate on these guys here. These guys right here. I'm only going to do one because I think I only need to do one because all of them will be identical in the way they behave. So let's just do 2. This guy right here that I have called 2. I think I can do it on one page, or I'll just move it up. That's okay, no problem. I'll do it down here. Okay, so let's do the 0 that I have called 2. All right, we're starting here. We're going up here. Okay, so I've got 0, and then from that 0, where can I go? I can only go here. I can only go here. Oh, but I can also go here and here. There are quite a few choices there. Got 4 choices from that 0. Okay, so let me draw that in carefully. So I've got a 0, right? I can go this way 0. I can go that way 0. I can go down a diagonal to 0, and I go down a diagonal to 0. All right. Okay. I hope so far you're with me. Now let's concentrate on each of these zeros that I went to. This guy, how can I get a 5? 1, 2, 3, 4, 5 ways. All right, let's draw that in. So 1, 2, 3, 4, and 5 ways. Now let's concentrate on this guy. That 0, how many 5s? 1, 2, 3, 4, 5. Okay, same, exact same. So, boy, 1, 2, 3, 4, and 5. Okay, now let's concentrate on this guy. 1, 2, 3. Only 3 ways to get to that final 5. So 1, 2, 3. And finally this guy here, 1, 2, 3, 3 ways. So 1, 2, and 3. Okay, I think we're done. So how many different paths? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 for the path that I denoted 2. Now the good news is that there's going to be exactly the same scenario for the other guys that I have called, what did I call them? 4, this one right here, 5, and the 0 that I denoted with the 7. And that's it. I've done it all. So now let's add them all up. We've got 6, 6, 6, and 6, so that's 24. And we've got 16, 16, 16, and 16. That's what, 64. So that looks like 88. 88. So the answer for number 23 is E. A positive integer is called a perfect power if it can be written in the form a to the power of b, where a and b are positive integers, and b is greater than or equal to 2. For example, 32 and 125 are perfect powers because 32 equals 2 to the power of 5, 125 equals 5 to the power of 3. The increasing sequence 2, 3, 5, 6, 7, 10, ... consists of all positive integers which are not perfect powers. The sum of the squares of the digits of the 1000th number in this sequence is not perfect powers. That is what this is. So what that basically means is that if you're going to write out all of these numbers, right, 1, 2, all the integers from 1 till some number, obviously, but let's just say 1 till 1,000. I'm not going to write them all out, don't worry. Until, let's say, 1,000. What we have to do is subtract from these, take away from this list, all the numbers that are perfect powers. And they've done that for the first few, right? They took away the 1, they took away the 4. What else did they take away here? They took away 8 and the 9, right? Because those numbers are perfect powers. And what they had left, 2, 3, 5, 6, 7, 10, they have put into this list. And we have to do the same. But we have to do it for the numbers all the way up till 1,000. But not to worry, it's not going to be as painful as you think. Because the good news is there's not as many perfect powers as you may think. You might think that there's like hundreds or whatever, right? There isn't. There's probably only going to be a few dozen. And that will take a little bit of time, but it's not too bad. All right, so let's just quickly make a list. 1 to the power of n. Any of those will be called a perfect power, as long as n is greater than 2. They're calling it b, I call it n, same thing. All right, well, what are those? Well, it's only going to be 1, right? Because 1 to the power of anything is 1. So that's easy. 2 to the power of n, what are those? When n is greater than or equal to 2, we got 4, 8, 16, 32, 64, 128, 256, 512, and 1024. I'm not going to go any higher than that because I think, we just want to get up to 1,000, right? 3 to the power of n. Let's see here. 9, 27, 81, 243, 729, and I think that's it. We don't need to go further than that because if we do, it'll be much more greater than 1,000. 4 to the power of n, 16, 64, 256, 1024, and I'll stop there. 5 to the power of n. We got 25, 125, 625, and then I'll just stop at that point. 6 to the power of n, 36, 216. I don't need to go further than that because that'll be quite a bit more than 1,000. 7 to the power of n, 49, 343. 8 to the power of n, 64, 512. 9 to the power of n, 81, 729. 10 to the power of n, 100, 1,000 exactly. And before I continue, let's keep a tally here of how many I got. For 1 to the power of n, I'll just do it on the side here. 1 number. For 2 to the power of n, how many did I get? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. I'm only going to use the ones less than 1,000. If I need it, if I need this guy later, I'll add it later. 1, 2, 3, 4, 5 for 3 to the power of n. 4 to the power of n. These ones I'm going to cross out because they are all included here, right? So you got to be careful about that. 5 to the power of n, I've got 3 unique ones. 6 to the power of n, 2. 7 to the power of n, 2. 8 to the power of n, they've already been counted, so I'm going to cross those out. 9 to the power of n, I've also been counted up here, so I got to cross those out. 10 to the power of n, I've got 2 unique ones. All right, so let's continue with this list. Now, at this point, what happens when you get to 11 and so on, that you're only going to have one number. Because if you keep going 11 to the power of, 3, it'll be far greater than 1,000. So I'll just make the list from 11 all the way up till what number? It's until I get to 1,000. So it's basically 31. So let me make the list and I'll come back. So here we go. This is our list here. And we got to cross out a couple of these that are doubles. 16 gives 256 when you square it, and that's already been counted up here somewhere like that. What else do we have doubles of? I think 25, this one, because that's going to be included here. Any others? 27, I think. 729 is already in here somewhere. Right here it was. And it's actually right there. And I think that's it in terms of doubles. So that's not actually that bad of a list. Let's make our tally here. These are all individuals. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'll put an 18 here. All right, so what do we have in total? 1 plus 8, which is 9. 9 plus 5 is 14. 17, 19, 21, 23, and 18 gives me 41. I've got 41 numbers that are between 1 and 1,000 inclusive that I cannot use in this list right here, in this list, because we want only numbers that are not perfect powers. And what I just made, this big long list here, were perfect powers. All of these were perfect powers because they can all be written in the form a to the power of b. So from 1 to 1,000, 41 of them I gotta get rid of. So if I do that, I'm left with just 959 numbers, correct? Now I've got to get up to 1,000. Okay, no problem. That means that this list, ... has to go up another 41 to account for those numbers that I took out. So it's got to go up to 1,041. Correct? Now, this is the part of the question that is not necessarily extremely difficult, but it's something that people would miss. And I made sure that I wrote it in there. 1024, don't forget about him. That is going to be somewhere in here, and that also has to be taken out. Why? Because it's a perfect power. It's in our list. So that means when you take that out, you got to go up by another number. So you got to go to the 1,042nd number. Correct? And that will be the 1,000th number in the sequence. All right? 1042. Now they want you to figure out, what do they want you to figure out? The sum of the squares of the digits. Okay? Our number is 1042. The sum of the squares of the digits. That would be 1 squared plus 0 squared plus 4 squared plus 2 squared. And that is 1 plus 16 plus 4, and that's 21. And therefore, the answer to number 24 is 21, and that would be choice E. In the diagram, right-angled triangles AED and BFC are constructed inside rectangle ABCD, so that F lies on DE. If AE is 21, ED is 72, and BF is 45, what is the length of AB? So first and foremost, let's utilize the fact that these are right triangles to figure out some distances. AE, they tell us, is 21, and ED, they tell us, is 72. So we can easily figure out AD using Pythagoras. AD squared will be 21 squared plus 72 squared. correct? And that looks like AD will therefore be 75 if you do that math there. So I'll just write 75 up here. All right, anything else that we can figure out? I think so. They give us that BF is 45, that distance right there. And we just figured out that AD was 75, so obviously BC will also be 75 since this is a rectangle. So that will also give us a Pythagorean relationship. We have BF squared plus FC squared is equal to BC squared. And BC is going to be 75 squared. FC is what we will figure out. And BF they give us in the question is 45 squared. So if you do the math here, you'll get FC is equal to 60. So I'll just put that there, 60, and BF they gave us in the question is 45. Okay? And I think that is the first part of the question. Pretty straightforward. Now, where do we want to go from here? At this point, I'm going to draw a perpendicular from the top all the way to the bottom. So that green line is going to be very important for us in this question. And I'm going to label some of these points here. Where it touches BC, I'll call it G, just to be consistent with our letters A, B, C, D, E, F, G. And where it touches AD, I'll call it H. Okay? All right. Now, this is going to be the heart of the question. The first thing, of course, is I want to concentrate on trying to figure out FG, that distance. So from here till here. Now, that can be done pretty quickly, considering the fact that you have this triangle here. And that triangle, the area can be calculated in two ways. The first way, of course, is 1/2 base times height, using 45 as the base and 60 as the height. So that's the first way, 1/2 times 45 times 60. And now another way is to use this as the base and this as the height, FG. So that would be 1/2 base, which is BC, and BC we know already is equal to 75, since that's a rectangle, and then our height is FG. Now these two ways of calculating the triangle's area are equal, right? Because the area is the same, regardless of which way you do it. So this will allow us to figure out FG. And if you do this math, you'll get FG is equal to 36. All right, so I'll put that 36 in there right there. Now I'm going to calculate F to H, that distance right there. If I can do that, then I can add it to my FG, and that will give me the length of AB, which is exactly what they want. Okay, now let's concentrate on FH. FH. Okay, so how do we do FH here? FH, I'm going to have to label a few things here, but fortunately they're not that complicated. This is a right angle right there. Okay? And if this is, say, angle theta, then this would be right here 90 minus theta. Correct? And in a very similar way, if you look at this triangle, just that one, this is also 90 minus theta. So I've got a similar triangle situation here. This triangle right here, which would be, I guess, in terms of letters, DFH. DFH triangle is similar to this guy right here. That is what? ADE. ADE. And because they are similar, the ratio of the sides are the same. So here we go. FH, which is this side right here, so that's the side that includes 90 minus theta and 90, would be the same as this one, AE, in terms of the ratio. And that would be equal to the ratio of two other sides. So I'll use, say, HD, which would be the 90 and the theta side. And the 90 and the theta side on the other triangle is this one, ED. So HD over ED. There you go. And I think this should do it. Let's see here. FH, well, that's obviously what we're trying to figure out. AE, do we know the length of that? Yes, we do. It's 21. And then HD, from here to here, do we know the length of that? Actually, we don't. But it's okay. I can figure it out. HD would actually be the same as GC, correct? Since this is a perpendicular right there. And GC I can easily figure out using Pythagoras. It'll basically be GC is equal to 60 squared minus 36 squared, like that. Right? And that gives me GC is equal to 48. So therefore HD is also 48. So HD is 48, and I'll put that there. We're still continuing this relationship. And ED, well, fortunately, they give us that in the question. They give us that in the question stem, actually, 72. All right, we got it. So doing the math here, we get FH is equal to 14. And there you have it. We've got the full distance. They want you to figure out AB, correct? I think I can squeeze it in here. AB is equal to FH plus FG. And both of those we figured out. FH we figured out as 14, and FG we figured out as 36. And therefore 14 plus 36 is 50. So number 25, the answer is A.